Mr. Richmond, this is your Integrated Math 2, Unit 13.2 and 13.3 lesson summary. In Unit 13.2, we're going to focus on how to multiply polynomials together now. We've done addition and subtraction already. So today we'll focus on multiplying. And while we're at that, we'll go ahead and move into 13.3, which is about factoring polynomials. And as you know already, what factoring is the idea of undoing multiplication basically and bringing it back to the original multiplication problem. So if I had 6, how could I factor 6? Well, I could change it back into a multiplication problem such as 2 times 3 or 1 times 6. What we're going to be doing is factoring polynomials, which is a little bit more complex, but generally the same idea. So one property we're going to add to the list of properties we've learned already is the symmetric property of equality. This might be kind of obvious to you at this point in the course, but just in case it isn't, here it is. The symmetric property of equality states that if m equals n, then n equals m. It's idea of symmetry. If this was an axis of symmetry, m is the same as n. If you flip it, did a mirror symmetrically, it's the same, n equals m. Why even bother? Well, sometimes when students try to solve out equations for x, they get their variable on the right-hand side and they have something like 3 equals x, and some have trouble realizing, well, that's the same as just writing x equals 3. So this just states that it's okay anytime you have an equal sign to switch what's on the right side and put it to the left, and what's on the left side to put on the right, just to have it look more, appealing to you. So, with that out of the way, let's jump right into how to multiply polynomials. We'll start by multiplying a monomial, 1 term, by a trinomial, 3 terms, and then we'll take a look at a binomial times a binomial, 2 terms, 2 terms, and even take it a step further into a binomial times a trinomial. Now keep in mind, you could keep going. You could do a trinomial times a trinomial, 4 terms times 4 terms. The process is the same, it's just more work, takes a little longer to get there. So you can really do any of these strategies I'm going to show for these, okay? Before we do that though, I want to make sure we understand a fundamental difference here between adding polynomials and multiplying. I've said this once and I'll say it again with math. It's one of my favorite analogies to do is to explain this with kids. They tend to remember it is addition, subtraction, and math is kind of racist, right? They don't get along, they're bigots, whatever you want to say. It's not a good thing, but it's how they are. 4x will not add with 2x squared, okay? And you might even go, well, Mr. Richmond, they're the same race, they're x and x. But they even take it to the point of class. This one is more powerful. It's x squared, it's more wealthy, whatever you want to think of it as, but it has more power. It's a higher level citizen than this one. So even that alone will make it so they can't combine. So 4x plus 2x squared will not add because their powers are not the same. However, like I've said previously, with multiplication, they're kind of the hippies. They want everyone to come together, let's keep everything together, love and peace, etc. Talked about this over and over again. But here, same thing. If it's multiplication, it doesn't care. It'll multiply together. 4x and 2x squared, let's bring that together into 1x with more power. Let's put our wealth together is kind of the idea. So multiplication is the universal combiner and aligner here for this stuff. So something like 4x plus 2x squared is done. You're not going to be able to add that. There's no like terms. Multiplication, no big deal. Here's how it works. We can't obviously combine a number with a variable in any other way other than it is here, but we can multiply those two numbers together. So 4 times 2 is 8, and then you can multiply the x's together. How do x's multiply together? Their powers increase. This is a power of 1, this is a power of 2, together they're a power of 3. So when you multiply 2 variables together with the same base, etc., you can add the exponents. So this would become 8x cubed. Okay? If I did 4x squared times 3x squared, that would be 4 times 3 is 12. X squared times x squared is now x to the 4th. Okay, etc. So you add the exponents together. A little bit of pre-knowledge just to make sure we're able to be successful here. So let's get this started. Let's multiply. The only property you've really done so far with this type of stuff is the distributive property, which is taking an outside terms and multiplying by everything on the inside. So why change things on you? If that's been working, let's just apply that now to more terms. 3x times x squared is 3, and I got multiplied by the number in front of x squared, which is just 1. So 3, x times x squared is x cubed. Now I take the 3x to the times 5x. 3 times 5 is both positive, so plus. 3 times 5 is 15. X times x is x squared. And 3x times 1 3 times 1 is positive, so it's positive. 3x times 1 is just 3x. And I've now multiplied that out. When it says simplify, they mean if it does end up having like terms, they want you to combine those. Here there were no like terms, and it's already in standard form, so I'm set to go. If it's not in standard form, you should probably put it in standard form. Okay? For multiplying binomials, one of the common phrases, at least back in the day when I was learning this stuff, was FOIL. That's how some kids remembered it. The way the book is going to look at this is through algebra tiles or an area model. And that's fine. I think it's great. You can work through the book on that. But at some point, you're probably not going to want to go through the trouble of doing an area model every time. It's kind of like wearing your training wheels on your bike. It's great for the first time through, but now it's time to ditch those training wheels and do this kind of the grown-up way. So let's go right to the grown-up way. FOIL is the idea of multiplying the first, the outer, the inner, and the last, which is, again, is great. It's a great way to remember it. But I still think the easier way is just to think of it as distribution. This is 3x times everything. This is x plus 3 times this. I just have to take x, multiply it by everything, distribution, and then 3 hasn't done any multiplication yet, so now it has to multiply by everything. So it's really just double distribution, same thing as the idea of FOIL, first, outer, inner, last. Now I have 4 multiplication problems, so I should get 4 different term answers. Let's work it out. X times x squared is x cubed. X times negative 1 is a negative 1x, which I can just write as a negative x. Now I can move to the second set of distribution. 3 times x squared is positive 3x squared. And 3 times negative 1 is negative 3. Look for any like terms, cube, squared, x, constant. No like terms, but not in the correct order, so let's put it in standard form. X cubed first, then my 3x squared, then my negative x, then my negative 3. And now we have successfully multiplied that out. Okay, for my last one, I can show you 2 methods, and I'm going to show this way first, which is sticking to the same strategy. So this might work best for you because it's just more distribution. But now I'm still just doing double distribution. X times x squared, x times 6x, x times negative 1. And now negative 2 needs to multiply by everything. Negative 2 times x squared, negative 2 times 6x, and negative 2 times negative 1. Now I'm going to do one thing to take this a step further. When you have this, I'm going to end up with 6 different terms that I'm multiplying out. And the problem that can arise when you do that is you're going to have a lot of stuff you need to combine, and it can get a little crowded, get a little confusing to kind of find everything. So I do something a little different. When we add numbers, like if I was adding 317 and 62, I want to line things up. Constants line up, add to 9, the 10 digits add up and combine, and it kind of makes my addition happen quicker than it would if I thought about it this way. Okay, it's just a little more efficient for us to add down this way than horizontally. So when I set my terms up, I'm going to put like terms vertically with each other. So let me show you this method. Again, you don't have to do this, it's just a thing to try. X times x squared is x cubed. So that's my first term. Nowhere to put that yet, so I'll put x cubed. X times 6x is 6x squared. That's a new term. So no problem, no confusion yet. It's still in order, so 6x squared. X times negative 1 is a negative 1x. So again, a new term. No reason to do anything different. Put the negative x. Now I'll move on to the negative 2. Negative 2 times x squared is negative 2x squared. Now rather than put it here, why don't I line it up with the term it's going to end up combining with anyways. So I can put my negative 2x squared there. Now I'm starting to line up the right digits. Negative 2 times 6x is a negative 12x. And again, I'm lining that up under the x's because that's what it's going to combine with. And lastly, negative 2 times negative 1 is a positive 2. That's a new term I haven't had yet. And here's ultimately what I'm trying to combine together. Now I don't have one of everything, so the ones that don't just carry down. But now I have my like terms lined up in nice neat columns. X cubed is just x cubed. 6x squared minus 2x squared is a positive 4x squared. Negative x and negative 12x makes a negative 13x. Negative 1x and negative 12x is negative 13x, and I carry down to plus 2. And the nice way about that method is keeps everything in standard form for you. It makes it really easy to find your like terms. Okay? Now, I don't I don't know if they go into it this way yet. And honestly, for a lot of kids, this is actually a kind of a more difficult way. But as you move into Math 3 and you start having to multiply tougher terms, sometimes students like to start thinking of it like how you would do long multiplication. If I was doing 312 times 42, I'd line it up this way, and I do 2 times 2 is 4, 2 times 1 is 2, 3 times 2 is 6. Then I put a 0 holding place. 4 times 2 is 8, 4 times 1 is 4, 4 times 3 is 12, and then I'm adding these up to get my final answer. Well, I can take this same strategy to multiplying polynomials. Okay, I'm going to end up with the same answer, but it's just working it out in this same type of way. Negative 2 times negative 1 is positive 2. Negative 2 times 6x is negative 12x, and negative 2 times x squared is negative 2x squared. Put a 0 holding place. X times negative 1 is negative 1x. X times 6x is negative 6x squared. And, wait a minute. Oh, x times negative 1 is negative x. I'm sorry, I messed up here. X times 6x is positive 6x squared. I put negative, I was looking at the 1. And x times x squared is x cubed. And so it's a similar process, but you'll notice it kind of creates the same thing I did here, and I can combine down and get the same answer. But my guess is, at least with my experience teaching it, like this is the most successful way for most of my students. But hey, choose your method you like the best. All right, moving on to factoring. And this is kind of a partial picture of factoring. We are going to learn a few more ways to factor in this section to deal with some kind of tougher polynomials, but for now, for the initial set of polynomials you're going to run into, these two factoring methods will work, and they're really the way you start on all of them. The first thing you always want to try to do, always, is factor out a GCF first. Even if you don't think there's one, look for one, make sure. If there's not, then you can move on to step 2. But you may not move to step 2 until step 1 has been done or is not possible. So you factor out a GCF first. We've talked about that already. A GCF is any number or variable that goes into all 3 terms. So what goes into 2x squared, negative 6x, and negative 8? Well, 2 does. So I take the 2 out and I divide everything by 2. 2x squared divided by 2 is x squared. Negative 6x divided by 2 is negative 3x. Negative 8 divided by 2 is negative 4. This is now factored, and if I was to multiply this out, it would get me back to the original. What's going to be a little more complex now is we now expect you to factor this a little bit further. X squared minus 3x minus 4 is a factorable trinomial. So if there are 3 terms left, you can try factoring using the diamond method. Now the book does not show this. They show a modeling way, an area model way of doing it. That's fine. Again, I've taught this for a very long time. This has always worked the best for me personally and for the students I've taught, so I'm going to show this method now. It may not even be a method your teacher uses, but if you like it and you can get it to work successfully, you can show it to them, or maybe they'll want to share it with the class, etc. It's up to you. But I do this. So if I have a quadratic trinomial with x squared, I take the last term, the constant, and I make a little cross. We call it a diamond, but it's really just a cross. And I put the last number, the constant, in the bottom, the negative 4. So I wrote constant there. And I put the b term, the coefficient in front of x, in the top, and that would be negative 3. So notice the signs are included. And what I'm going to do is list all the multiples of the bottom number. What multiplies to 4? 1 times 4. 2 times 2, and that's an important step. Make sure you include the multiples. And I'm going to look for any combo of these 2 numbers that could add or subtract to this. 1 plus 4 is 5. 1 and 4 subtracted is 3, so that works. 2 and 2 adds to 4. 2 minus 2 is 0, so that doesn't work at all. So that lets me know right away that the correct numbers to use in this problem are 1 and 4. Now, the key here is just making the negatives work. I want these 2 numbers to multiply to 4, or in this case, sorry, multiply to negative 4, but add to negative 3. So I have to choose 2 numbers that multiply to negative 4 but add to negative 3. And the only way I'm going to find that is by listing the multiples of 4 and choosing the one that could potentially add to that. So what would it have to be if I'm going to subtract these? I need the 4 to be negative, because 1 minus 4 is negative 3. That's the only way that's going to work. And just to make sure it works here, 1 times negative 4 is negative 4. I found the right factors. Now, all diamond problems, all quadratics factor to a distribution problem. Okay? And what this does is it gives you a method to get there without having to guess and check, which is the way your book is likely showing you, is setting this up and starting to guess what numbers could go here. This simplifies that process. Okay? So what I do is if the number is positive, I write x plus that number. If the number is negative, I write x minus that number. So my factored term is x plus 1 times x minus 4, and it always has this form of a binomial times a binomial. And the order you write it doesn't matter. I could put x minus 4 first, and then x plus 1 if I like. Okay? Your choice there, that's kind of like the symmetric property, really. So let's now attempt that with a problem or two. So first one says factor. Again, step 1 first, always, GCF. 2 goes into 2 and 6, I'm going to take out a 2, and they both have a y term, and I take the lowest one that they both share, which is y, and now I have the GCF. I'm going to see what these are when they get divided out. 2y cubed divided by 2y is y squared. 6y divided by 2, or sorry, negative 6y divided by 2 is negative 3. And I've taken out a GCF, and this term is not a trinomial, so there's no way I'm factoring it this way. I've done the only 2 steps I could do. So I feel pretty confident that that is as factored as it's going to get. So that is an example of one that you can only factor by GCF. Next one, B. Step 1, factor by GCF. X, no x, so I can't take out an x from anything. 1, 7, 12, no common term there except 1. So I cannot factor by GCF. So at least I tried. So I can go to step 2. It is a quadratic trinomial. I make my diamond. What's my bottom number? The constant, 12. What's my top number? The number in front of the x term, negative 7. And now I'm finding all the multiples of 12. So I'm going to list them. 1 times 12. And honestly, you can stop once you see one that could add or subtract to 7. 1 and 12 will not do that. 2 and 6 adds to 8, subtracts to 4. That ain't going to work. 3 and 4 adds to 12. Oh, sorry, adds to 7, subtracts to 1. So that does become 7. So I found my numbers are 4 and 3. But I need to make them work to multiply to 12, but add to negative 7. Make them negative. Negative 3 plus negative 4 is negative 7. Negative 3 times negative 4 is positive 12. I found my factors. Now it's just a matter of setting it up as a binomial times a binomial. And again, the steps here is once you have the numbers, it's just a matter of taking the correct variable, in this case x, and writing it as x minus 3 and x minus 4. And now I have the correct factoring. Now, I will show you that it's true here by working it out here in our heads. If I factor something correctly, it should always multiply back out to the original. And so you can check any factoring answer. There's no reason to ever get them wrong. 2y times y squared, 2y cubed. 2y times negative 3, negative 6y, it checks out. X times x is x squared. X times negative 4 is negative 4x. Negative 3 times x is negative 3x. That combines to a negative 7x. Still matches. Negative 3 times negative 4, positive 12. And again, you can work that out by hand at home if you'd like. I'm going to try to go a little quicker, but it does work. You can verify it yourself. Moving on to the last example. C, and the first thing you're going to do is you're going to see trinomial, diamond, yay, get to work, right? But no, you got to avoid that temptation. And still, no matter what, be disciplined and always factor out a GCF first if possible. What do they all have? 3, 27, and 60. 3 goes into all of those. So I need to take a 3 out of each of these terms. If I do, I get this. 3 times n squared is 3n squared. 3 times negative 9n is negative 27n. And 3 times 20 is positive 60. So I factored out a GCF. What I am left with, though, is still a factorable diamond. So I need to continue working. Now, don't forget about that 3. He's still technically there. He's just going to wait till the very end to see what he's being times by. So I need to do my diamond. My diamond this time is 20 and negative 9. So I'm going to list multiples of 20. 1 and 20, but I can tell already that's not going to add a 9 or subtract a 9, so I'm skipping that one. 2 and 10. 2 plus 10 is 12. Nope. 2 and 10 subtracted is 8, close but no cigar. 4 and 5 multiplies to 20. 4 plus 5 is 9, that's the one. 4 and 5, and let's see if it can make that work. It needs to subtract a 9, so these both need to be negatives. Negative 4 times negative 5 is negative 9. Negative 4 times negative 5 is positive 20. I have my correct factors. Just make sure to continue taking that 3 down, and it should be 3 x minus 4, because once I have the factors, it's just a matter of writing it as parentheses, and x minus 5. And so sometimes you do have to factor by taking out that GCF first, and then working the diamond out, and then it becomes a multiplication problem between your GCF and your diamond. Okay? And in my original problem that I did, it would be very similar. I didn't work it out that way, I tried to show it separately, but notice here I took the 2 out, and it's factored by GCF. But since I know here that x squared minus 3x minus 4 factors of this, this now can technically become a final answer of 2, and this, which becomes this. So x plus 1 and x minus 4 would be that factored completely. So hopefully that helps. I wish you the best. You definitely want to practice with factoring. It's going to be crucial in the next section as well as the next chapter. So not a skill to take lightly. You want to be really, really good at factoring. So good luck.